The Sahara stretches the width of the continent. Covering 9 million square kilometers, it spans 11 countries. But surprisingly, a discovery on the other side of the desert, in Israel, promises to reveal vital clues about the human journey out of Africa. The discovery was made in the 1930s by the first female professor at Cambridge University. And what she found was staggering. Archaeologist Dorothy Garrett was leading an excavation on the slopes of Mount Carmel. Outside a cave known as Shul, they uncovered stone tools similar to those found at Pinnacle Point in South Africa. But even greater treasures were found when they dug 1.5 meters down, almost to the bedrock outside the caves. The remains of 10 human skeletons. After painstakingly chiseling out the blocks in which the remains were entombed, Garrett's team encased them in plaster and carefully lowered them to the valley floor to be taken for conservation. Today, they lie in the Rockefeller Museum in Jerusalem, in the exact positions in which they were found. These bodies had been carefully buried, and some were laid to rest with grave goods. One was found clasping the jaw of a wild boar. It seems likely they were buried this way for a reason, and that they had a belief in the afterlife. It's the first time in the human story we see clear evidence for supernatural belief. These were fully modern humans, and their bones have been dated to around 100,000 years ago. But how did they end up here, on the far side of the deadly Sahara? There's another new branch of science that could help: climate modeling. We've commissioned some of the world's top climate scientists to work out the climate in every part of the world, but not for the present, for the past. For months, simulated models were processed by supercomputers and have revealed details of changes in temperature, rainfall, sea level, and vegetation.
There have been some fairly dramatic changes in climate over the last 100,000 years or so, say, and these would have had a big impact on modern humans in terms of how they live and where they can migrate to. And so in that sense it's very important to understand the climate over the whole of the globe at several points in the past.
So what does this tell us about how we left Africa?
The region of North Africa, the Sahara and the Middle East, you think of at the moment as being very dry. You think of deserts and lots of sand and very hot and arid, basically. But 125,000 years ago, it was actually fairly different to that. And if we run the climate model forward through time from 140,000 years ago, you can see, in particular, the region around the Sahara gets a lot more green when you get to about 125,000 years ago. You can see a kind of a northward extension of this green bit into the Sahara. It was a lot wetter. There were rivers and lakes and wetlands, and also the surface was actually quite well vegetated. This would probably have meant that animals and humans could have followed this as well.
So around 125,000 years ago, the climate radically changed, and the biggest, driest, most impassable desert in the world briefly blossomed. For a few thousand years, even the massive Sahara Desert would have looked more like the East African plains. A welcoming home for animals and our ancestors. Gradually, humans could have followed the game further north. Eventually, some arrived in Israel, where they lived for many thousands of years. So is that the mystery solved? Is this how we left Africa? Well, these are certainly the oldest remains of our species found anywhere outside of Africa. But were they our ancestors? It seems not. The astonishing finds in the Mount Carmel caves are the end of this archaeological trail. No other evidence has been found anywhere to suggest humans survived here or continued the journey. The story of this particular pioneering group does not seem to have a happy ending. And once again, it may all be down to the climate.
We can run the climate model forward again from about 125,000 years ago and see what happens. And what happens over North Africa and the Middle East is that, as you can see, all that green has effectively got a lot more dry, a lot more arid, there's a lot less rainfall occurring, and so the vegetation has been replaced by desert. There would have been less water available, and so in effect it would be a lot harder place for people to have lived, and certain regions would have been almost completely uninhabitable.
This expansion of the desert may have been disastrous for the people who lived in the Shkol caves. If the animals that they hunted for food disappeared, then starvation would have become a reality. And at the same time, the route across the Sahara back to Africa would have been shut. It seems that these people, the first of our kind known to have left Africa, simply died out. So if these people are not our forebears, what route did our ancestors take out of Africa? We know the Sahara had turned back to desert, so we can pretty confidently rule out a northerly exit route. Which leaves just one remaining option, the sea. So what would be the most likely sea crossing for a group of early African hunter-gatherers? One option is the Red Sea. It separates Africa from Arabia, and at its narrowest point, it is only 30 kilometers wide. The Arabic name for this place is the Bab el-Mandeb, which is usually translated as the Gate of Grief. But new research suggests that in an ancient language of southern Arabia, a better translation would be the gateway of the crossing. Could this be a clue as to how we left Africa? Whilst 30 kilometers may not sound like much, it's a huge barrier if you don't have a sea-going vessel. So how might people have made the crossing? Ironically, it may have been down to the same change in climate that trapped the people in Israel.
At the same time as the Sahara is beginning to dry out and North Africa is forming large deserts again, we're heading into a glaciation. So that means formation of big ice sheets over North America and Europe, which lock up water from the ocean, and this means a drop in sea level occurred. And we can run the model forward through time to see this. And if we look in the Red Sea region, we can see that a lot of new land is being exposed because of this. And when you get to about 70,000 years ago, you can see that there's a lot of new land around here, and that the distance to cross from Africa over to the Arabian Peninsula by sea is reduced greatly.
In fact, this drop in sea levels meant that the shortest distance across the Red Sea fell to just 11 kilometers. Was this the opportunity people needed to take the leap from Africa to the rest of the world? They may have had good reason to make the journey. As the climate changed, plains dried out and the sea became more salty. Their sources of food were under threat. The pressure to find new lands and opportunities may have made a starving population risk everything and make the crossing. A journey that could have happened sometime around 70,000 years ago. But if the crossing itself wasn't tough enough, what awaited them on the other side seems even more treacherous. Today, Arabia is a brutal desert, not dissimilar to how it would have been at the time of this potential crossing. Temperatures in the heart of the Arabian desert reach 50 degrees Celsius. It's one of the hottest places on the planet. Did our ancestors really manage to survive in this place? It sounds unlikely. But Dr. Jeff Rose is not one to be put off by a challenge, even the challenge of finding evidence in such a forbidding place. He's one of just a few archaeologists to search for clues to our ancient past in this region. And he believes that this dead place was once alive with our ancestors. To test his claims, we took him on a route through the Arabian desert which he had never seen before, and asked him if he could find any signs of ancient life.
It's actually quite a special location. If you look around, you see all these black rocks that are lying across the surface. Well, they're not really rocks. They're all ancient stone tools made by early humans. Well, I've picked up a few just lying on the surface here. And these are called cores. So these are the pebbles they would have held in this hand. They would have had a harder stone in this hand, and they would have knocked flakes off of this, which would have then been turned into tools. And these particular cores are called blade cores. So it's a very specific technology where they're trying to remove these long, thin blanks, which would then be turned into scrapers or arrowheads or something like that. And this is a particularly interesting one because we can see they've removed flakes here and here, and then they got themselves into trouble. They hit it here. They didn't hit it quite hard enough, and you get what's called a hinge fracture running along this edge here. And it's a mistake. So they probably just said, and threw it over the side and picked up another